Good morning, students. How are you? Today, we will discuss about the numericals regarding the topics which we had discussed in previous video, and the numericals are based on the topics absolute error, mean absolute error, relative error or fractional error, percentage error. So, one numerical is in front of you. Look at the numerical and try to understand the numerical. After that, I will discuss what is your strategy regarding solving these type of problems which are based on errors. So, according to this numerical, in an experiment, any experiment had been performed to measure the refractive index of glass, and the refractive index of the glass was observed in 5 experiments are 1.45, 1.56, 1.54, 1.44, 1.54 and 1.53. 5 times the experiment had been performed, and in 5 times we had got the refractive index of glass as 1.45, 1.56, 1.54, 1.44, 1.54 and 1.53. Then we have to calculate mean value of refractive index. As we had studied, mean value of refractive index, mean absolute error we have to find, then we have to find the fractional error, after that we have to find percentage error. Apart from this, we have to express the result in terms of absolute error and percentage error. Whatever the result which is coming, the result should be expressed in the form of absolute error and percentage error. So first of all, what is our strategy for solving the numericals based on errors? First of all, we have to read the problem carefully and be sure to understand the nature of the problem before proceeding further. What is the nature of the problem? What is asked? You have to go through it first. Then you have to level all physical quantities. You have to level it. Suppose here refractive index of glass is given. So according to your supposition, you can level mu1, mu2, mu3, mu4, mu5 and mu6. After that, which type of arithmetic operations is required in the given problem? You have to see that. You have to apply the operational formula to analysis of the error. For the analysis of the error, you have to apply the formula. Now, if there are equations, then we have to solve the equations to find out the unknown quantities and then check the answer. So this is the strategy. First of all, you have to, the main thing is that you have to read the problem, then you have to mark the level the quantities. Suppose here, suppose mass is given, then m1, m2 and m3. So now I am solving this problem. Look at here. So first is mean value of refractive index. Mean, first one is mean value of refractive index. We have to find out mean value of refractive index. So mean value, suppose we had taken it as mu, then mu bar is represented by mean value. Mu bar means mean value, and it is equal to mu1 plus mu2 plus mu3 plus mu4 plus mu5 plus mu6 divided by 6. This is the mean value. Now 1.45 plus 1.56 plus 1.54 plus 1.44 plus 1.54 plus 1.53. All the values given in the question: 1.45, 1.56, 1.54, 1.44, 1.54, 1.53, and whole divided by 6. On adding it and then dividing by 6, we will get the value 1.51, that is the mean value. So we had obtained the mean value of the refractive index. Mean value of the refractive index we had obtained. And this mean value is what? Mean value of refractive index can be treated as true value. This is the true value. That is mean of all the measured quantities, mean value of all the measured quantity is the true value. It is the true value. Now we have to find out the absolute error in measurement. Absolute error in measurement. Second thing is absolute error in measurement. Absolute error in measurement. Absolute error in measurement. Absolute error in measurement. And that absolute error is what? Del mu is equal to true value or mean value, true value or mean value minus measured value. Measured, true value or mean value minus measured value. So del mu1, it is equal to 1.51 minus 1.45, and we will get the error 0.06. Del mu2 is equal to 1.51 minus 1.56, and it is equal to minus 0.05. Del mu3 is equal to 1.51 minus 1.54, that is equal to 0.03. Del mu4 is equal to 1.51 minus 1.44, and it is equal to 0.07. Del mu5 is equal to 1.51 minus 1.54, and it is equal to minus 0.03. Minus, this is also minus 0.03. And del u6, mu6, all these are refractive index. Mu6, 1.51 minus 1.53, that is equal to 0.02. Means what the mean value or true value we had obtained in the previous calculation, in the previous part, the mean value or true value we had obtained. From that true value we had subtracted the measured value, and after subtraction we got the error in the measurement of refractive index 1, error in the measurement of refractive index 2, error in the measurement 4, 5, 6 and so on. Clear? Now this is the absolute error in the measurement. Now we have to find mean absolute error. Now we have to find mean absolute error. Mean absolute error. mean absolute error, that is mean del mu bar. Mean absolute error is del mu 1 plus del mu 2 plus del mu 3 plus del mu 4 plus del mu 5 plus del mu 6 divided by whatever the error obtained in the measurement of refractive index of 1, 2, 3, 4, 5, whatever the error, the mean value of the error is mean absolute error. And as I had discussed while discussing the topic, I had discussed this thing. So it will be, and here we will take only the mod magnitude, not positive or negative error, only the magnitude of the error. Here we take, here for mean absolute error only we consider the magnitude of the error, and it is equal to 0.06 plus 0.05 plus 0.03 plus 0.07 plus 0.03 plus 0.02 divided by 6, and it is equal to 0.26 divided by 6, and it is equal to 0.0433, that is equal to 0.04. It is equal to mean absolute error. Now we have to calculate the fractional error or relative error. We have to calculate the fractional error or relative error. We have to calculate the fractional error or relative error. Fractional error. Fractional error oblique relative. Fractional error oblique relative error. Fractional error or oblique relative error, that is delta of mu, that is fractional error, it is equal to mean absolute error upon mean value, true value. Mean absolute error upon true value, and the mean absolute error is 0.04 upon true value is 1.51, and it is equal to 0.02649. 0.02649. On rounding off, you can write it 0.03. Now, percentage error. Percentage error. This percentage error is what? This percentage error is the relative error del u upon u into 100, that is equal to 0.03 into 100 percent, and it is equal to 3%. Percentage error is equal to 3%. So these all the errors we have calculated. Now the last section is we have to express the result in terms of absolute error as well as percentage error. So result in terms of absolute error and percentage error. Result in terms of absolute error. Result in terms of absolute error. Result in terms of absolute error. So the absolute error is of mean absolute error is 0.04, and we have got the true value we had got 1.51, and mean absolute error is plus minus 0.0. So in terms of mean absolute error, the result means our result may vary from 1.51 plus, either it is plus 0.04 to 1.51 minus 0.04. This is the variation of, this is the range of variation of result. Means the true value can be varied plus 0.04 or 1.51 minus 0.0. Next one is in terms of percentage error. In terms of percentage, in terms of percentage error, in terms of percentage error, you can express the result as 3%. Percentage error is 3%, so 1.51 plus minus 3%, or it will be equal to 1.51 plus 3% to 1.51 minus 3%, plus 3% to minus 3%. So this is the result in the form of error. We have calculated all these things. Now we will try for another question. Look at here. The same thing in the another question. I will solve here 3 questions, and one question I will give you to solve at your home. You will try to solve by putting the, you try to solve the question by putting the pause button, not seeing the solution on the board. Write the question. In successive measurements, the readings of the period of oscillation of simple pendulum were found to be 2.63 second, 2.56 second, 2.42 second, 2.71 second, and 2.80 second. For an experiment, this is the time period of oscillation of simple pendulum. It is given here. Now you have to calculate the same thing. You have to calculate the same things. You have to calculate. First one is mean value of the period of oscillation. Mean value. First one you have to calculate mean value. Second one you have to calculate absolute error in each measurement. Absolute error in each measurement. Third one is mean absolute error. Mean absolute error. Fourth one is relative error. Relative error. Fifth one is percentage error. Percentage error. And The last one is express the result in proper form. Express the result in proper express the result in proper form. So all the methodologies we had discussed in the previous question also. Now it is very easy for you to solve this question automatically. So solve this question, and I am also solving the question. Look at here. Mean period of oscillation. The first one is mean period of oscillation. Mean period of oscillation, and it is given as, suppose this is time, so time period, so there it was refractive index, so we had taken mu. Now here the time period, so we had taken it is considered as t bar at t, that is equal to mean value of time period 2.63, 2.56, 2.42, 2.71, 2.80 divided by 1, 2, 3, 4, 5 observations, so divided by 5, and it is equal to 13.12 divided by 5, and it is equal to 2.624 second, and it is equal to 2.62 second. By rounding off by 2, we will get rounding off up to 2 decimal places. We have got 2.627. The second one is absolute error in each measurement. Absolute error in each measure. Absolute error in each measurement. Del T1 is equal to what? This is the true value, 2.62, minus the measured value, 2.63, and it is equal to minus of 0.01 second. 01 second. Del T2, that is 2.62 minus of 2.56, and it will get 0.06 second. Del T3, that is equal to 2.62 minus 2.42. It is equal to 0.20 second. Del T4, 2.62 minus 2.71, and is minus 0.09 second. And del T5, 2.62 minus 2.80, and it is equal to minus 0.18 second. This is absolute error in each measurement. What is the error in each measurement? Absolute error in each measurement we have got. Now mean absolute error. Next one is mean absolute error. Mean absolute error. Mean absolute error means mean of the all errors in occurred. What is the whatever the mean of all the errors in occurred is mean absolute error as we had discussed. So del t bar, mean of all the errors, and here we will only consider the magnitude 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 divided by 5, and from here we will get 0.54 divided by 5, that is 0.108 second, it is 0.11 second. By rounding it up to 2 decimal places, I will get. Now this is mean absolute error. Now relative error. Relative error. Now relative error. Relative error, and this relative error is delta t, and this delta t is equal to del t bar upon t bar, and del t bar is 0.11 upon 2.62, and this is equal to 0.04198, that is equal to 0.04. This is the relative error. Percentage error. Percentage error, and this percentage error is 0.04 into 100%, and it is equal to 4%. This is percentage error, 4%. Now you have to express the result in terms of absolute error as well as percentage error. So for absolute error, result in terms of absolute error and percentage error. Result in terms of absolute error. Result in terms of absolute error means t is equal to 2.62 plus minus 0.11 second, and the result in terms of percentage error, that is equal to 2.62 plus minus 4%. Second. So this is the result in absolute error and percentage. Now there is one question. The diameter of the wire measured by a screw gauge. A screw gauge is a device to measure the diameter of any object. You will see it in your physics lab about a screw gauge, what is a screw gauge, and how the diameter of any wire can be measured by the help of a screw gauge. So it is given in the question. Try to solve this question. The diameter of a wire, the diameter of a wire as measured by a screw gauge, as measured by a screw gauge is 1.328, 1.330, 1.325, 1.334 and 1.336 centimeter. Here also you have to calculate mean value of diameter, mean value of diameter, second absolute error in each measurement, absolute error in each measurement, absolute error in each measurement, mean absolute error, mean absolute error, fractional error and percentage error. Mean absolute error, fractional error and percentage error. Now try to solve this question. I am giving you the solution of this. First one is, that is mean value of diameter. Mean value of diameter. Mean value of diameter, that is d mean, and it is equal to 1.328 plus 1.330 plus 1.325 plus 1.326 plus 1.334 plus 1.336 divided by 6. It is equal to 7979 divided by 6, 1.3298, and it is equal to 1.330. This is the true value. Now, error in each measurement. Error in each measurement. Absolute error in each measure. Absolute error in each measurement. Absolute error in each measurement, that is del D1. First error in measurement of diameter, and 1.330 minus 1.328. 1.330, that is equal to 0.002 centimeter. Del D2, it is equal to 1.330 minus 1.330, and it is equal to 0. Del D3, it is equal to 1.330 minus 1.325, and it is equal to 330 minus 325, and it is equal to 0.005 centimeter. Del D4, 1.330 minus 1.326, and this is equal to 0.004 centimeter. Del D5 is equal to 1.330 1.330 minus 1.334. Here we will get the negative value and minus 0.004 and del D6. Now writing here del D6. Del D6. It is equal to 1.330 minus 1.336 and it is equal to 1.330 minus 0.006 minus 0.006. Okay. Now this is the absolute error in each measurement. Now we will discuss mean absolute error. Mean absolute error. Mean absolute error. Mean absolute error. The mean absolute error is del D mean. Del D mean, and it is equal to del D1 plus del D2 plus del D3 plus del D4 plus all the mean. Del D5 plus del D6 divided by 6 and it is equal to 0.002 plus 0 plus 0.005 plus 0.004 plus 0.004 plus 0.006 divided by 6. So it is equal to 0.021 divided by 6. It is equal to 0.0035 and on rounding of 0.004. This is the mean absolute error. Now fractional error and percentage error. Fractional error and percentage error. Fractional error. Fractional error, and this fractional error will be del D mean upon D mean, that is true value, and it is equal to plus minus 0.004 upon 1.330. D mean we had got 1.330 and this is equal to plus minus 0.00 plus minus 0.003 plus minus 0.003. Now percentage error. Percentage error, and it is equal to 0.003 into 100%, that is equal to what? 0.3% plus minus 0.3%. The percentage error will be 0.3%. Now diameter of wire in terms of absolute error. In terms of absolute error, it will be 1.330 plus minus 0.003 centimeter, and percentage error, in terms of percentage error, D will be equal to 1.330 plus minus 0.3% centimeter. So this is all regarding the numericals. This is sufficient numerical based on this, and this is all about the numerical part. Now, in the next video, we will discuss about combination of errors, and the numerical based on combination of errors we will discuss in the next video. So that's all for today, students. Thank you. Have a good day.